efficiency project. We're here to talk about cities and counties, what they should know about building electrification policy. And we have three presenters today. Myself, I'm the Buildings Program Director. I'll also be moderating. Matt Lacey, the Division Sales Manager for the Southwest with Daikin, and Christine Brinker, Senior Associate with the Buildings Program at SWEEP. So us three will be presenting today over our time. And we will be talking about three focus areas. I'll be talking about the policy options for electrification through building codes. And then heat pumps, the way to electrification, and that's Matt's time, where he'll be talking about the benefits for home builders, homeowners, what things look like. And then we'll follow up at the end with heat pump water heaters that are also a key component. And that will be Christine. She'll be a live stream as a walkthrough of a heat pump water heat install. We'll have Q&A after each presenter. There's a question function. You see there's a chat. We're going to be using the question function. So the question function, click that, enter your questions. We'll capture that. We'll have questions after each presenter, as I mentioned. And then we'll have, depending upon our time, questions at the very end. Okay, and so I'm going to close down this webinar, or excuse me, this presentation real quick and bring up my presentation. Okay. I have it up. Okay, let's get into this. We're going to be talking about building electrification today. And so first off, SWEEP, Southwest Energy Efficiency Project. Some of you may be joining outside of the SWEEP region. And we're one of 6 regional efficiency organizations. That's why I put the picture up there of all the RIOs. And we focus on 6 Southwest states. You can see us on the left in orange. And we are here to advance energy efficiency through these states, through many mechanisms and policies, and to advance it through the economy. So if we look at where we were 10 years ago, 10 years ago we were in the middle of a housing recession, building recession, and there's been a major shift in those 10 years. So 10 years ago we were talking about net zero energy buildings. We weren't talking about building electrification. In December of this year, it would have been 10 years that Chevrolet released their Chevy Volt, their plug-in hybrid electric vehicle. And so things have changed dramatically since then. And so many changes have occurred. They're converging, and it makes it more attractive for electrification to occur today than it did in the past. Rapid growth in lower cost, zero emission power that we're seeing. We're seeing decommissioning of coal plants, future plants, those that have already closed. We're seeing movement to wind and solar and other clean energy. Technology advances have also happened over the time frame. And so now we've got smart technologies. Think of a smart thermostat in the house. And then building management systems have improved dramatically for commercial buildings, where things can be controlled on a mobile device. And then think even further technological advances of things that are all connecting into Alexa or the other home devices. And then the EV growth. So we just saw the Chevy Volt 10 years ago. Now we've got Teslas and Leafs and BMWs and many EVs that are in the space today, and many more coming online in the next few years. Also, at the same time, the electric utility industry is trying to maintain low energy costs for the consumers and the businesses. And so load management is critical for them. And then also over the last 10 years, municipal and state emission reduction goals have changed. There were many cities that had climate goals 10 years ago, but many have implemented goals climate goals and policy since then. And even over the last 4 years, it's even accelerated even more, where city and county policies have gone into play. So it's shifted. Now it's a good time for electrification. And so let's just define building electrification. It's just moving or upgrading, if it was an existing building, but moving equipment that would otherwise run on natural gas or propane to clean and efficient electric versions. And we say efficient too because we don't want to go from a gas forced air furnace to electric baseboard heat, which is not efficient. So we want to move to efficient electric appliances. And so air source heat pumps are one, which Matt will be talking about, heat pump water heaters, which Christine will be talking about. So our opportunities for building electrification, these are some of the areas that's happening. Cooking, clothes drying, those are other areas to also move to electrification. But we're just going to focus on, from a building perspective, the heating piece and the water heating piece. We already know heat pumps have been operating for many years effectively and efficiently in hot climates. But today, technology is there where these systems can operate in colder climates. And a lot of the Southwest, as I showed earlier, the sweep region is in cold climates. So we wrote a report, and it's available. You can look for it on the handouts. You go over to your dashboard in GoToMeeting, and you'll see 4 downloadable handouts, or you can go to the sweep website, swenergy.org, and download it. What we had is a number of communities asking us questions of how they can move forward with building electrification, how they could advance policies, ordinances, and their building codes to require building electrification, commercial and residential buildings. So we looked at, across the country, cities that had implemented some policies and what they did. And then we also looked at opportunities of how we could support municipalities in our region. And so we included code adoptable language in this report. So feel free to download that. What we found was 6 approaches to electrification. And so one is incentives. So you say, you know, I'm a city or I'm a county and we're going through this COVID right now. It's a challenge. Funds are a challenge. Well, the incentives, there's different types of incentives, but one is expedited permitting, expedited field inspections that can incentivize a builder to move towards electrification. Electric ready. That's one that we like, where it's pre-wired. So wherever you have those gas appliances that we just showed pictures of, you also have an electric outlet there. So the panel, the wire, and the outlet is in place so that the consumer can put in either gas or electric. It's very optional for the home builders too, or any building, even on the commercial space, to be able to choose at the last minute between an electric appliance or a gas appliance. Electric preferred is another option we found. That you can build, we want you to build with electric, but if you're going to build with fossil fuels, natural gas or propane, well, we need you to do more extra efficiency or renewable requirements added to the building. Another was building specific types, going after a specific building type. Could it be a single family detached house, a multifamily, a commercial building, a retail space in commercial, a office space? So that's, and then the last 2, electric only with exceptions. That was where communities found they wanted to go electric, all electric, but they couldn't. They had some issues. So principally gas stoves, cook stoves for residential, and even for the restaurant space, the industry. So allowing gas stove, but everything else was electric. And then last, electric only. That's what we found communities have adopted and are operating under these 6 different processes today. So what did cities and counties have to go through to get here? They needed to have a sustainability plan. That was one of their foundational requirements. The building and sustainability departments had to have a good relationship, collaboration between those two to understand what the city's goals are and what the building department, how buildings fit into it, and what buildings are required to do to meet those goals. And then support of the Council and Commission. Now, the Council and Commission already gave support of their sustainability plans. But this is also getting the Council or the Commission support for building electrification, because some industry will be coming in and saying, we are a little concerned about going to electrification. And so the Council and Commission needs to be on the same path with the building department and the sustainability department, saying, this is our path, this is the way we're going to go. Extensive outreach was another area. So the building industry had to reach out to architects, engineers, home builders, building owners, developers, the apartment industry for multifamily, trades, manufacturers. They all were brought into that process to have the discussion of moving that community forward for their goals, of their climate goals, and now their building electrification goals. Along with that, there was a timeline and a roadmap to reach those goals that was worked through with that outreach, because there were some, depending upon the community, depending upon the industry there, a timeline is a stepping stone to get to your final goal. And so these communities have looked at this. That's why some communities have said, we did electric preferred and we allow gas in some areas. Eventually, they're going to move to an all-electric, electric-only code. And then ongoing collaboration for the built environment. So what we're going to talk about, these communities focused on new construction. It's easier to focus on new construction to bring electrification into new existing buildings. There's more requirements on that area, but it's very doable, as Matt will be talking about that following me, and Christine will also be talking about a renovation for a heat pump water heater. So where's your code? This is a good question. What code are you on? If you're not on the 2015, you need to get up to where we're at today. You really need to move to the 2018. 2021 is next. Will be coming out sometime next year. But when we looked at helping these communities, what was the code in place? The 2018 code was in place. It's a mature code. It's been in place for a few years now, released 3 years ago. And industry is more comfortable with 2018. We've seen a lot of adoptions of the 2018 code in the Southwest. And so this is really a good place. And this is where, when we wrote our adoptable code language and included that in our report, we aligned that with the 2018 energy code. So, as I mentioned, we created adoptable code language in the California cities that have required building electrification. One thing in California is the Building Energy Efficiency Standard, or Title 24, they already had some optional provisions for building electrification in their current code. So it was easier for those communities to just pull from some requirements that were already in the state code, and then add requirements to that. With the IECC, the International Energy Conservation Code, which is the primary code adopted throughout the U.S. We don't have anything like that. There are no appendix sitting out there, and there's no optional code out there for building electrification. And building codes are dense with detail. They take time. They're time consuming to develop. So we looked at the commercial code language from all of these communities and the residential code language. We moved it into code language that fit within the IECC. So here's some case studies. I'm going to go through the next few slides. Case studies of cities that have moved forward with electrification. So Berkeley's one of the first you heard, electric only. They said, we're going electric only. Berkeley's 120,000 in their population. They only are seeing about 300 homes per year being built. Now, we didn't include the commercial space, challenging to get that data, costly to get that data too. But we also see as residential construction goes up, commercial construction follows residential construction also. So then Winter, California, another city in the West, they only have 27,000 people, and they brought electric only into their building codes. So on the electric only with exceptions, this, remember, is you can do electric, and we're going to allow you to continue to include gas stoves, gas cooktops. So in Brookline, Massachusetts, which went through the entire process, all the approvals were ready to move forward, and then the state came in and said, nope, you can't move forward. Not yet. We have a statewide code. You can't go beyond this. And so Brookline and other Massachusetts cities are working with the state, looking at opportunities for stretch code provisions within the state code where electrification could be included. But Brookline, they found a lot of pushback. They allow backup generators. So if you have a natural gas backup generators, that's one of their exceptions. That was different. We didn't find it in any other community. We found gas cooktops to be the principal one. And then in Santa Rosa, it was gas fireplaces out in California, my old stomping grounds. A larger community of 177,000 and a larger amount of new construction at 1,200 new homes last year. And so their option is gas fireplaces can be included. Everything else is electric. So each community, you can see, does it differently. There's needs, there's the politics of each community is different. But realize that electric only with exceptions, you can make exceptions for what is in your community. Electric preferred. What I mentioned on the earlier slide, electric preferred is the community wants to go all electric, but if you include a natural gas or propane systems within your home, then you're going to have to include more efficiency or renewables to those buildings. So San Luis Obispo out in California, great. You want to do that? Fine. You're going to have a more efficient home. You're going to have some requirements, specific requirements on the panel capacity for heating systems, water heating systems. Boulder here in Colorado, where I'm located, has gone a different route, and they have included the larger the home you have, the more efficient it needs to be. And that's also with a HERS score. So the lower the HERS score gets, the more challenging it is to get there with fossil fuels. And so in Boulder, they're using the HERS score for residential. and driving those scores down. They continue to drive those scores further and further down and moving those buildings more and more to electrification. And the last one I want to talk about here, and I'm checking my time so I give Matt and Christine enough time. This is the electric ready that I talked about earlier. Now the 2021 IECC, which is not yet released, it'll be released maybe December this year, most likely next year. That had a proposal for pre-wire, for electric ready for residential. So gas water heaters, gas dryers, gas cooktops needed to also have the electric service, the panel, the wire, the outlet there. This was approved by the ICC membership, which is governmental members. So that's cities and states and counties that are members of the ICC. Following the ICC policy, the governmental members voted this proposal in. They also voted in an EV infrastructure proposal. Well, unfortunately, some special interest came forward, didn't like these proposals, and there was a long appeal process, and eventually the ICC board, just a couple weeks ago, rejected these nationally vetted, approved by ICC governmental members. So this pre-wire proposal that should have been in the 2021 is not there, was rejected by the ICC board. But this language is still available. We've included it in our report. There'll be other organizations that will be including this and the other proposals that these special interest organizations were successful with having removed from the 2021 code. That we'll be seeing more and more of those available by other organizations that are supporting this level of building electrification. The benefit here, this was nationally vetted. Went through that long process, nationally vetted, and then voted on by governmental members. So, coming up to the last couple slides of my presentation. So our recommendation, we like electric preferred. That's, if you're not ready for all electric, you want to take that step, electric preferred. So you're saying electric, but if you have gas, then you're going to add some increased efficiency requirements. There could be some renewable requirements in there, and that's balancing the equation towards electric. At a minimum, what I just talked about with that proposal for the 2021 IECC is adopting the electric ready. So homes and buildings are pre-wired, and the owner can convert their appliances to electric at any time, and they can take their buildings over to a clean energy source at any time in the future. So, sweep, those are the ends of my slides. This is my last slide. We work in supporting municipalities in our region, the Southwest, and supporting with climate goals, electrification, advancing zero energy, and advancing energy codes. So we've got the three of us, and this is just not all. We have Neil, Christine, and myself located here in Colorado that are working in this space, but we also have Karen in Arizona, Tom in Nevada, Kevin in Utah, and Tammy down in New Mexico that are working with us to support communities and states that want to move forward with these initiatives. So we will have time for a few questions. And Christine, do you see any questions in the question box or even in the chat?
Yeah, there was one question that came in mentioning that electricity prices tend to be higher than natural gas prices in a lot of states, and given that the new electrified equipment can sometimes have higher first costs than conventional gas technologies, but they're so much more efficient. Have we seen any economic analyses or studies that compare what the costs would end up being at the end of the day. So I sent that question answer some links of the studies we've seen. We did a study a couple years ago. That was one of the first ones out there. That was by Neil Colway at SWEEP. And we've also recently seen a pretty good analysis from Group 14. And I just got an email today about a new study from RMI, but I haven't read through it. So I sent those links to the question answer, but if anyone else has the same question and wants those links, I can send those on. And Jim, do you want to add to that answer?
No, that's great. And then Matt might, when Matt comes on in the next minute or so, he might also be able to answer that. But there are a number of studies out there that are looking at this. Good question. Looking at electric costs, natural gas costs, cost of the equipment. We are seeing cost of equipment come down, and we anticipate the cost of equipment will come down as it becomes adopted, especially if it becomes part of a municipal building code or ordinance.
And another couple questions are coming in. Tell me, Jim, when we have to jump over to Matt, but we'll take
okay, let's take another one, Christine.
Okay, there's about two questions about how cities are working with utilities to get the grid ready, especially since these technologies will use more electricity.
Can you say that again? I'm sorry, I missed that.
How are cities working with utilities to ready the grid? And given the growth in electric usage and while consuming more is green, what about the generation needs?
Yep. Good. Very good question. So these communities are talking with the utility. So I should have added to that list of the stakeholders, the utilities. These municipalities are also working with the utilities. So the utilities understand the city or county has their goals, they're moving to their goals. How can that utility support that? So here in Denver, we've been participating with Denver as Denver's moving forward. They have a goal to get to all electric buildings, to zero carbon. And they are working with Excel Energy locally. Just recently, and I think this will be my last question to answer. Just recently, California just said their cars by 2035, all new cars will be all electric by that date. Las Vegas, Nevada is looking. The utility there is looking to say, all these Californians driving up from Southern California coming to Las Vegas. How can we support that need when they need to charge and head back home, head south on a Sunday afternoon or whatever that may be, a Sunday evening? So yes, utilities need to be part of that stakeholder group. And they are, as I mentioned, as there's change in the shift of where we are today from 10 years ago, utilities are looking at the demand growth and the load management piece too. So I'll stop there. If I can capture the rest of these questions, I can answer them individually. And then I'm going to pass off at this point over to Matt. Where are we? Okay, I'm making Matt Lacey the presenter. He's going to be talking about air source heat pumps, and that's an area where there's a lot of questions for the electrification piece, especially on the heating side. Okay, Matt, it's yours.
Okay, thanks, Jim. All right, you guys got my screen?
Yes.
Yeah.
Okay. All right, thank you. So, all right, so today I'm going to be talking about, yes, my house. And before I do that, I thought it would be important to say a little about me, since I'm going to show you what my home looks like and why I made the decisions on whole home heating and cooling that I did. But then after I talk about myself, I'm going to talk a little about Daikin, and then I just want to kind of set the bar on what the options are when you're looking at replacing your HVAC system. So to start off, a little about me, my personal life, I'm a husband and father of two. I absolutely love being a father. It's the greatest job I've ever had. I was also in the Army for 6 years, so I'm a veteran. I'm a problem solver, love fixing problems. I am currently a Colorado resident and live in the beautiful city of Parker. And if you haven't heard, it was voted the second best city in the United States to live in. Very proud of that. When it comes to work experience, as Jim mentioned earlier, my current title is Division Sales Manager for the Southwest United States for Daikin North America. Prior to this position, I was the Senior Product Manager for all the United States for our ductless products. So I'm quite familiar with our brand strategy and the trends that the HVAC market is heading in. I also have done a lot of different things in sales and retail, and I put some positions I've had up there on the screen. But I've also got a technical background. I was an excimer laser engineer before, and I troubleshot avionics when I was in the Army. So I'm not a typical sales guy. I've got some technical knowledge behind me. I think it blends out who I am professionally quite well. But it also allows me to answer questions as technically as they need to get, I guess you could say. So a little about Daikin. We're the world's largest HVAC manufacturer. We have $17 billion in sales annually. 91% of that business is HVAC. 7% of it is chemicals, and there's other parts of the division that make up 2%. We've been in business since 1924, and we have over 100 production bases worldwide. Our business is broken down into three major pillars. It's air conditioning, filters, and chemicals. We're the only air conditioning manufacturer that also makes refrigerant. And if you haven't heard about R32 and A2L refrigerants that are coming, it's coming pretty soon. I think 2023 is our first product launch of R32 refrigerants. And then globally, we have a vision at Daikin for a goal in 2050 for lowering greenhouse gases. And there's a handout that you can download. That's our global sustainability document. If you want to read more about it. But the message there is that we're not just a company who makes air conditioning, we're a company who tries to make air conditioning responsibly. And here locally in the United States, we've built the third largest manufacturing facility. Only Boeing and Tesla actually have single level manufacturing facilities larger than ours. Our interior office and our meeting rooms at the DTTP in Texas have achieved LEED Gold, which was quite an achievement for us to do that. It's a large facility, so being able to achieve that, we're very proud of that fact. One of the other great things about this facility, other than the fact it's located in the United States, is that we really have this collaborative way of thinking about business. Our R&D labs, our marketing, our engineering, manufacturing, sales are all under one roof. So when there's a topic that we really are trying to get to the bottom of, we come together in a room and we don't leave until everyone has action items when they leave that room. And I worked out that facility for 2.5 years. It's an amazing facility to have been in. And if you ever get a chance to go to Houston, Texas, make sure you head out to the DTTP and take a look at it. It's an amazing facility. And here locally in the United States, we employ 17,000 people. We've invested over $7 billion here in North America. And we've been in the United States for 25 years. So we really are committed to the development here in the United States. And then now let's just move into some of the basics. Now, what are the options in whole home air conditioning? Typically, what you see is a central AC gas heating system. That's what most people in the United States have. And generally, it's a single or two-stage system. There are what we call inverter type systems and variable speed type systems, but typically it's a single or two-stage type system is what you see in the market. It uses ductwork to distribute the conditioned air throughout the space. And ductwork typically is leaky and dirty. I don't know if anyone's ever seen inside of a ductwork in an older home. It can get pretty gross inside there, but that's important to know that it's ductwork that gets the air from the furnace or the air handler or coil to the rest of the house. Another thing a central AC system usually has is one temperature control. There's one thermostat that controls the temperature for the whole home. Gas furnace provides heat, and a gas heating system, obviously. And then we use this analogy of when it's on, it's all on. If you were to turn your light on in your living room, all the lights would come on in your house. That's how a typical central AC gas heating system works. You get one temperature throughout the whole house, and that's your only option. And then moving on to a central heat pump system, it's about the same thing as a central AC with gas heat. It's a single or two-stage system, uses ductwork, one temperature control, but the outdoor unit in a heat pump system can produce heat. But typically what you see in colder climates is that heat isn't enough, so you have to have some type of supplemental heat in the form of a gas furnace or some type of electric strip heat, which just isn't efficient. And then once again, when it's on, it's all on. And then we move on to the third system, and this is really more of the future of HVAC, the decentralized heat pump system. And with the decentralized heat pump system, it uses a variable speed inverter technology system. And I'll talk a little bit about that on the next slide. I don't want to get too much into the weeds, but I'll talk a little bit about that. There's very little to no ductwork. We can use ductwork, but if we do, it's very short duct runs and very easy to maintain. Each room has its independent temperature control, so everybody can have their own comfort levels, and I'll explain that in another slide here in a minute too. And then the outdoor unit produces all the heat the system needs, so no need for gas furnace and no need for electric strip heat. This heat pump system produces all the heat needed in cold climates. And then the greatest point I love is that it can take advantage of renewable energy. It's all electric, so any kind of solar panel system that goes up, I can take full advantage of that with this system. And then this is just a really quick understanding of what inverter versus non-inverter is. And a non-inverter system is basically all on when it's on. An inverter system will ramp up to meet its desired need. Kind of works like the accelerator does in your car. If you only want to go 45 miles an hour, you only have to go 45 miles an hour. You push down as hard as you need, and you go that speed. With a single system, with the electricity on a single stage system, it's all on or all off. That's it. And you can see in the off state, an inverter system will ramp down. So it slows down. It doesn't have to turn off as it meets room temperature. And if anybody has any questions about this, we can discuss it later, but this is just a basic overview of inverter versus non-inverter. Okay, so now let's dive into my house. And here are the reasons why I went with a decentralized heat pump system. So as you can see here, this is Parker, Colorado. It does snow here. It gets into the single digits in the wintertime. It's a beautiful place to live. And one of the reasons I chose a decentralized heat pump system is if you look at the outdoor unit, there's a space-saving option. The outdoor unit can be mounted just about anywhere you want because it has such a small footprint and a small clearance requirement. So you can see on here the before and after. There was my central AC system. It was probably 30 years old, wasn't working, so we had to replace it. And we opted to go for this decentralized system, heat pump system, which turned into a much cleaner installation on the outdoor. And then on the inside, it really allowed us for a flexibility of design in remodeling our basement. So this is a picture of our basement, and the ceilings were just under 7 feet tall. So I think they're about 6'10". So I could easily, I'm 6 foot tall, so I could easily walk in the basement, stick my hand up and touch the ceiling, and just felt like you were kind of cramped and like you were in a basement. And the reason why the ceilings were so low is because there was all this ductwork in the ceiling. And because we went with a decentralized heat pump system, we didn't need this ductwork any longer. So we were able to raise the ceiling up to 8 feet, which really now represented a living area that we were proud of. You walked into the basement, it doesn't feel like a basement anymore. And here's just a side-by-side of a before and after. And we did some other things, obviously, so we closed off a room and put a door in. But it really does make this feel like just another level of the house versus a basement. Same thing in the kitchen, flexibility of design. If you look at the door jamb and the ceiling, you'll see the ceiling comes right down to the door jamb. And then same thing with the window over the sink. The ceiling comes right down to the window edge. The reason why is the ceiling was dropped down to allow for ductwork that fed a bedroom upstairs. Since we went with a decentralized system, we didn't need that ductwork. So we removed that ductwork, raised the ceiling back up, and then we're able to remodel the kitchen and actually make it look like a kitchen we could be proud of. And you walk in, you didn't feel like you were walking into like a hobbit's kitchen. It feels like a normal kitchen. And if you look at the door jambs here on the side-by-side comparison, you'll see that we got about a little over a foot back in ceiling height on the remodel. And then same thing here with the flexible design. We had ductwork in the walls, so we had 2 returns there, and you can see through that little cubby hole, that was the old kitchen. And once again, we didn't need this ductwork, so we were able to open up the floor plan and really, allow for a nice area where we felt like we weren't constricted in the living room or constricted in the kitchen. It really flows nicely through the house now. And that was all through eliminating that ductwork that was really dirty and leaked a lot. And in fact, on the picture on the left-hand side, the before, you can see that there's bedrooms above the kitchen. Those bedrooms never got any air. They were always either hot or cold. The old system just was not satisfying the zones up there at all. And then this picture, you can see here, this is another shot of our living room and dining room after it was remodeled and the system was installed. And if you look out through the windows, you can see that it's cold outside. It's been snowing. The system's on and running, and it keeps the house nice and warm. My wife was opposed to this system initially because she was afraid of having something on the wall. She thought it was going to look, unattractive. But the payoff or the benefits that she now reaps are better than what she thought it was going to be. And what I mean by that is, for example, we sleep in a cold room at night. We love to be cold at night when we sleep. We get, under the blankets and stay nice and warm. But when we wake up in the morning, in our old houses, we'd wake up in the morning, we'd go sit on the couch, and we'd have to get all bundled up because it was cold, because, we had to have a cold house because we had a cold bedroom, and the old system only had one temperature. But in this scenario, we have this system that conditions our living room come on about 4 o'clock in the morning, and it heats up that living room to 72 degrees. So when we get up about 4:30, 5 o'clock, we get up out of our cold bedroom, we walk into a nice warm living room, and we're sitting on the couch, we watch news, and we drink our coffee, and we can enjoy a little bit of time before the kids wake up. And the other benefit is that the kids also can stay asleep in a cold bedroom. We don't have to turn a central system on that would then also warm up all the bedrooms. So my wife really loves that fact that we have this room by room control. Also, there was a lot of discussions about, whether or not this system could satisfy the heating load in the cold climate. And in fact, we had several contractors come out to our house when we were getting the system looked at before we had it installed that tried to talk us out of using a heat pump system and wanted us to use a gas furnace. And I kept explaining to them, my history. I've been the product manager. I know how this system works, and it will work. And in fact, I've had this room and that dining room and that kitchen up to 74 degrees when it was in the single digits outside. I had a picture at one point in time where it was 9 degrees outside and 74 degrees inside. You couldn't even tell it was cold outside. It was so warm and comfortable inside of our home. And I've even invited contractors back out to see this so they could witness it firsthand. So just to wrap this up in a summary, so a decentralized heat pump system allows for me as a homeowner to get more property back due to the small outdoor unit. I can mount that outdoor unit just about anywhere I want. I can mount it up high off the wall. It doesn't have to sit on the ground. There's lots of flexibility on the mounting of that outdoor unit. It's much quieter inside and out. In Colorado, we have a lot of radon gas, and I have a radon mitigation system. And if you stand outside next to my outdoor unit, you hear the radon mitigation system before you hear the outdoor unit running. That's how quiet it is. The radon fan is actually louder than the outdoor unit. And then a decentralized heat pump system eliminates the need for all that ductwork. So allows for me to have those tall ceilings in a retrofit or new construction application. And then it allows a lot of flexibility with floor plans. I imagine that if in the 80s when my house was built, if these decentralized systems were available, my house probably would have been designed with a decentralized system back then, just due to the way it was laid out. A decentralized heat pump system provides relief from my electric bill. They're much more efficient than a traditional system. And it's the year-long cost is much lower than owning a traditional system. And there was a comment about the upfront cost, so I would definitely like to address that. And yes, there is traditionally a higher upfront cost on a decentralized system than there is with a unitary system. And that's really right now due to economy, right? This decentralized heat pump system is not mainstream. Daikin has been manufacturing these systems for 50 years, and of course in Europe this is what's used. Asia, this is the normal thing that's used, but in the United States it's not. So we're working to make this more mainstream, and it is the future of HVAC. But the more it becomes mainstream, the lower the costs become. It also lowers the cost due to the fact that contractors get more familiar with it. If you look at examples in the Northwest, contractors up there are generally much more familiar with how to install these systems, so the upfront cost is much lower. But in parts here of the Southwest, some contractors really have no idea how to bid these jobs or install these jobs, so they bid really high, and then sometimes they win, and it's really the consumer who ends up paying for it. And that's one of the things that I'm working on at Daikin. I know Sweep's working on, and many other people throughout this industry are working on the education process. And we have many classes on how to educate people on installing these systems properly, so it does lower that upfront cost. And then from a decentralized heat pump system prevents me from needing supplemental gas heat. It lowers my carbon footprint, which is very important to me. It can provide a higher level of comfort, which my wife absolutely loves, and it's better for the environment because it doesn't produce carbon dioxide. And what I say by higher level of comfort, that's that room by room control. Generally, people think they're making one sacrifice. Well, if I go to an electric heat pump system, all I'm really going to do is, I'll be better for the environment, or be able to take advantage of renewable energies. But there's many, many positive trade-offs when you go to a decentralized heat pump system. And I think I've explained some of those in my presentation. A decentralized heat pump system also represents the future of HVAC. Like I said earlier, Europe, this is the primary product that's sold in Europe, is these decentralized heat pump systems. They typically don't use ductwork because they understand the inefficiency of using ductwork. And then last but not least, a decentralized heat pump system helps me satisfy my personal quest to achieve a net zero home and lower my carbon footprint. And that's a true statement. In the very near future, I hope to get solar panels put on. I'm just kind of waiting to see what happens in the next few years with policy to determine, if there's going to be some higher rebates or not. Solar is very expensive, but that is obviously one way we can help get these renewable energy sources into the market, is by incentivizing consumers to go ahead and make these choices with some type of a rebate. Okay, and that wraps up my presentation. So I'd like to end on any questions.
Great, Christine, you might have a couple, and I've got one here. Want to jump in
Yeah,
first?
a good question came in that I think everyone might want to hear the answer to. What's the difference between a heat pump and a mini split? Are those the same thing?
So yes, mini split is just a bad marketing term, I guess you can say. It is a heat pump. Typically in the market, a mini split means something on the wall. That's what people think generally, or something small. But the reality of it is that term mini split is just bad marketing. That product category is what I have on my home. By a product category, it is a mini split, but I'm satisfied my whole house with what we call in the industry a mini split. That's just a bad marketing term. What it really is a decentralized heat pump system. That's really what a mini split is. So it's very similar to a traditional unitary heat pump system in technology, but it's much more advanced in technology, which is why the decentralized heat pump systems don't need supplemental heat.
Okay, Matt, have another question here. Robbie is aware of the Daikin systems in Europe, and he is wondering if and when Daikin will be bringing their combined HVAC domestic hot water heat pump system to the U.S. market?
Oh, I love that question. So the Daikin Altherma, which is what he's referring to, is an amazing system. And it really is, it's just beyond revolutionary. We actually had it in the United States a couple years back. It was ahead of its time here in North America. Didn't get adopted as well as it should have back then. The problem we have now is most of Europe has moved to R32. Like they're ahead of us on so many initiatives. They've already lowered their GWP by moving to R32, and we're planning on doing so as well in 2023. So my hope is shortly after 2023, we could bring the Altherma in, because right now the Altherma is only made in R32. It's not made in R410A, so we couldn't import it to the United States. So hopefully shortly after 2023, we'll be able to bring the Altherma product in, which can produce heating and cooling in the space as well as potable hot water. It's an amazing system, so I hope that comes soon.
And that was called the what? The Altherma?
Altherma, that's correct.
Okay, so we'll look for that and pass that along to Robbie. So Kevin has a question here, and I know Christine's getting ready for the live stream. How many heat pump systems use climate-safe refrigerants with a low global warming potential? And you might have just answered that with what you were just talking about.
Yeah, right now in the United States, nobody makes a split system with R32. There are packaged systems, is what we refer to them, like window units that have R32. But it's not until 2023 that we'll really be introducing those A2L refrigerants like R32. So right now, everyone uses R410A. That's the industry standard in the United States.
Okay. And last question, I know there's a few here, and I believe we can capture all these questions and possibly get answers back to you. One person mentioned, Steve mentioned that having multiple units, they don't mix the air throughout the house like a central HVAC system, and so this is good for not moving viruses throughout the building.
That is absolutely true. Yeah, that's absolutely true. In a home, I mean, I don't know how much that matters. I mean, I guess if you have a big enough home and you're isolating somebody in one part of the home, that's true. But, you know, we start talking about schools and, you know, light commercial buildings where they do share a lot of air. That's absolutely true. And I was just telling my dentist about this the other day because he shares a package unit with his next door neighbor, which happens to be a hospital. And I was telling him about the concerns that he could have because obviously a person with COVID could go into that hospital and that package unit is just recycling the air and dumping it into his dentist's office. A decentralized system eliminates that for the most part. You do have configurations with ductwork where you could, if you want to design it poorly, I guess. But in its design, its nature, it's meant not to recycle air from one zone to another zone and just keep air conditioned in that one space. So it definitely can cut down on viral spread.
Great, thank you. Okay, Matt, thanks. And Christine has control. She's going to do a live stream right now. And then we'll have questions for Christine. And then if we have any additional questions with time, we'll answer those too. Thanks, Matt.
Hi, everyone. Can you see me? Or can you see my screen?
I see you and your screen.
Oh,
And
perfect. Okay. Good. Let me know if there's any problems. This is our first time doing a live stream, so forgive us any technical difficulties, but it's so much fun to show things live. Matt, I got to say, your system is so cool. And thanks for all the tour. It was really helpful when we were thinking about what sort of heat pump system we would put in our house to talk to you and compare notes on that. And our heat pump is a tour for another day, but for today, I'm going to show our heat pump water system. I can't quite tell what you guys are seeing, so you'll have to tell me if I have to rearrange my application so that you can see me and my slides. But this behind me, this is our heat pump system, and we absolutely love it. We're very happy with it. we would recommend it to anybody. In fact, I love to show it off wherever possible, but not many people share the same degree of my nerdy enthusiasm for energy efficiency. And fortunately for most of my friends and family with COVID, they're not able to come in and see a tour, but you guys are a captive audience, so you get the tour of our new heat pump water system. The reason we put it in is because we were doing a large basement remodel project to fix extensive water damage that we found in our walls. And in doing so, we found out that our old water heater was at the end of its useful life and it was likely to corrode out the bottom. And since we were fixing water issues anyway, we didn't want to have a future water problem. So we use that as an opportunity to get this new system. And when we were looking for a new water heater, we had several different priorities. Price, of course, that's the total cost of the system. Efficiency, environmental impact. So efficiency kind of relates to both of those things. The physical size and capacity. In other words, this is an existing house, so would it fit in the space that we have, and would it have enough hot water for our family's needs? And then the ease of availability. In other words, could we get it off the shelf from a store around here and not have to special order anything from Europe or so forth? So I'll talk in a minute about how we did on each of these priorities. But what we ended up doing, this one is an off-the-shelf from Home Depot Rheem 50-gallon hybrid heat pump water heater. Hybrid in this case doesn't mean natural gas and electric. Hybrid in this case means part of it is heat pump, and then it has a backup of some electrical coils inside it in case the heat pump can't keep up, which is very rare, but it just has that essentially as an insurance policy. This I think was probably the first link we saw on Google, and that's the one we got, although we did do extensive research, as is my habit, to come to that conclusion. And we put it in April, so it's been running a number of months now. It's similar to how a normal heat pump works for air, but this one's for water, where it pulls heat out of the air and it puts it in the water, and what you're left with then is colder air that it then spits out somewhere else. So it's really simple. And I wanted to remind myself a few things to tell you about it. So where it pulls heat from and where it puts the heat to, you kind of have some options there. If you're in a really hot climate, of course, in the Southwest, you would want to pull the hot air from the outside where it's very hot, and you would want to spit the resulting cold air into your house. If you're in a colder climate, maybe vice versa, but of course in Colorado we have both. So what we're doing is kind of cool, where we're taking the hot air from outside in the summer and we're spitting it into our house in the basement, and so we get free cooling coming out of here to supplement any other air conditioning. That's pretty neat. And then when winter comes around, we're just going to switch it around and go the other direction. So that's kind of how the ducting works. We were able to use an existing duct from our old furnace, so we didn't have to cut any new holes in our into our house. Something that's kind of cool that was a side benefit that we didn't even think about as we were considering what system to get is that the heat pump water heater has dehumidification, because as you cool down the air, the water condenses, and so you put that into a drain. And since we're trying to fix water issues in our basement, and since almost everybody tends to have a moist, damp, dank basement, then that's why this is a great advantage to this. Of course, some people put them in their garage and in mechanical rooms upstairs. Ours happens to be in our basement. It is tuned to 120 degrees, which is the lowest amount where you can still kill off all the bad little bugs, but still save as much energy as possible. So that's what all the energy efficiency experts recommend that you should set your water heater at, regardless of what type of water heater system you have. So go check yours, see if it's 120. If it's higher than that, think about moving it down to get a little bit of water savings. The trend nowadays is to get a system that is grid connected, and you get some really good incentives from your utility to do that so that they can help manage their peak demand. And this one is not, but shortly after we got it, I mean, we've only had it a few months, but since then they have this same model that is grid connected. So if I were buying this today, I would get that option that is grid connected. I'm going to show you a few stats with my last couple of minutes. As far as recommendations, we absolutely love it. I asked my 8-year-old just a couple minutes before this what she likes about our heat pump water heater, and she says it heats water. And so that's pretty basic. That's what it's supposed to do, and it does it really good. And she said, what do you like about it? And I said, I like that it is all electric and it helped us get off of natural gas. And she said, oh yeah, that sounds good. You should say that. Here's our stats. I know it's just 1 minute after. Whoops, sorry about that. I would love to tell everyone in more detail about how all the costs work out, but in the end, it comes to about a 5.8-year payback, and that is because when we put in our heat pump system for heating, we were able to cut natural gas completely, so we save that fixed cost of about $13 to $15 every month. So if I split that between our heat pump and our heat pump water heater, that's how I come to get about a 5.8-year payback for this system. Otherwise, it come out about equal. We do get really good rebates from our utility, Xcel Energy, but all of the major utilities in our area offer similar rebates. They tend to be about between $200 and $600, though there are some amazing ones out there. For instance, if I was in tri-state territory, I could have got about $1,300, and if I was in Boulder, I could have got about $1,400 and some dollars rebate, which would be amazing. So I was pretty jealous there. As far as efficiency, it's off the charts. It's way more efficient than a gas system, and that is because it's not generating heat, it's pulling heat from somewhere. It's just pumping it from one place to the other. And in terms of carbon reduction, it comes out to about a sixth of a car every year. And if I combine that with our new heat pump system for heating, in total, those two systems together equal about 2/3 of a car every year. So pretty good. I think we hit all of our goals there. I could talk for hours about any of these points, and I would love to, but we're low on time. So I think I will pass it back to Jim, and he can tell me if there are any urgent questions I should answer, or if not, we can always tackle those afterwards over email.
Okay, no, we can answer some, and you're ahead. We said we'd go to about 15 after the hour.
Oh,
so,
good. Okay.
Christine.
Yeah.
Yeah. The question is, what happens if your electricity goes out? How?
If electricity goes out,
that's from Rob.
You would not be making hot water. That's generally the same with almost any water heater, even the gas systems. Now, almost all of them still need electricity to do at least part of it. So nothing there. If it's out for a long time, you'd probably be taking a cold shower or going without. If it's out for a short while, I mean, it's a tank. It's got a lot of hot water in there, so it can last for a good while.
What's your electrical supply requirements is another question.
We didn't have to upgrade our panel or our supply. We did have to put in a 220 volt, essentially what they call a dryer outlet to plug it into. And those tend to run about $300 for the electrician. So we were fortunate to not have to upgrade our panels. Other people may have a different story, but so far so good.
Another question is a grid connected domestic hot water heater.
Mm-hmm.
What's the difference?
The difference is that if it's grid connected, it can be programmed to be heating water at night when there is an excess of renewables on the grid, and the utilities need some place to put all that extra wind power, and then you cannot heat it when they are having more of a shortage of power, so they can manage those peak times and run it when it's best. So you can program it to run it at certain times and not other times.
Okay, and is yours grid connected, the model you installed?
No, I wish it was, but it wasn't available when we got it. Now you can find this exact same model grid connected, and you would get a better incentive from the utility if you do that. I got $400. You would get $500 if it was grid connected for Excel, and some of the other utilities are similar.
Okay, great. Last question for you, Christine, and then we'll take some time to wrap up. I know Matt has a number of questions I want to run over to him. The noise level, is there a noise level from your typical gas water heater you had? What noise level do you notice?
I never really paid attention to the noise level for our system before, so I can't really do an apples to apples. Also, our last one had a door on it, and this one does not yet have a door on it, but I haven't noticed the noise being excessive for what it's worth. I mean, you can tell when it's on or when it's off. I mean, when it's heating water or when it's not. So you can hear some noise there, but I haven't noticed it being a problem. The heat pump itself is just totally silent. Even outdoors, it's basically silent, which is really nice. Our neighbors have a normal air conditioner, and it's hard to have a picnic outside because their air conditioner is so loud, but our heat pump system outside is pretty nice.
Great. And that's what Matt had mentioned too. So, okay, so Matt, I'm going to unmute you, and we'll take a last few. Matt, you'll need to unmute yourself. There you go. Okay, so I'll throw in a number of additional questions here, and continue to send in questions for Christine, Matt, or myself, and I'll look to see what we need to do, if we can include questions and our answers along with our recording on our website. So I'll check into that. Can't guarantee the question and answer piece. Question about, this is for Matt. Challenges, oh no, sorry, I'll get back to that one it's here, Matt, I apologize. It was Dave up in Boulder who asked the question. Quick question while I'm looking for that question. How many zones do you have in your house?
Currently, I have 7 zones that are conditioning my house. I have 3 ducted fan coils is what we call them. 1 ducted fan coil satisfies both my daughter and my son's room. So there's a return in each of their room and a supply in each of their room. The master bedroom on the main level has a ducted fan coil. And then in the basement, there's I guess you could call it a master bedroom. It also has a ducted fan coil. And then I have 3 wall mount fan coils, 1 in a bedroom, 1 in the main living area on the main floor, and then 1 on the main living area in the basement.
Okay, great. One question is, what are the trade-offs between a decentralized heat pump system with 1 outdoor unit and multiple mini splits?
Well, so going to multiple outdoor units, and I have a total of 2. Multiple outdoor units requires the electrical panel spaces. They are 220, so I use an existing electrical panel or electrical supply, I guess, for the old condenser. So there was no need to change that. I was able to downsize the circuit breaker. My old system required a 60 amp breaker. My new system only required a 30 amp breaker. And then I had to have I had the room on my panel, so I was able to have the electrical wires just ran to that panel and another breaker put in for the other condenser. If you're going to do more than that, you got to have more spaces. For me, a multi-zone decentralized system is really the way you want to go versus a bunch of one-to-ones, as we call them. So it's one outdoor, one indoor unit.
Okay, and that leads to this other question that I was looking for Dave out of Boulder was asking. It looks like there's one compressor to run all the heads for your home. How many heads are there? You said you had 7 zones. How many heads?
So 7 heads, 2 compressors. That's what it is. And so we, my HVAC experience, I came from the commercial side. So I was designing big buildings and HVAC systems for big buildings. And of course, I'm in air conditioning, so I probably went a little extreme more than I had to on my own home, but I wanted to make sure I got the comfort, the maximum comfort that I could. And I knew this was the way to go. So I did use a little design diversification. So one system satisfies one side of the home, the other system satisfies the other side of the home. So the idea is that no single one of my systems is on full speed. They're always on at what we call part load. They're barely running. So I'm not really using a whole lot of electricity with both systems running at what we call part load. So it's basically both of them are coasting all the time, which really produces a very comfortable environment at a very economic electric bill.
Okay, thank you, Matt. Next one is, we have a few minutes left. Christine, the question is multifamily. Elizabeth asked this question about the challenges of heat pump water heaters and multifamily projects and the space requirements. Can you address that? And I might be able to back that up with what's in our code.
Yeah, that's
language.
a good question. I've heard that that's a concern or something that multifamily owners and designers are working on puzzling through, but that it's not just an easy one-for-one swap. But I don't know the end result of what they're coming up with as far as workarounds. Jim, what have you seen?
Well, I know from the code space and in the looking at all the communities that have adopted electrification, they are looking at space requirements for heat pump water heaters, that you leave a certain amount of space around the water heater. And I think that might be what Elizabeth is questioning, because that's space, taking up space is importance to have conditioned space, living space available, as Matt showed us for the heat pump side. I do know that in the language that was proposed in the 2021, you only had to have the space if you left that space available if you did not install a heat pump water heater. If you installed a heat pump water heater, you didn't have to, but then you would follow under the manufacturer requirements. So, say, Elizabeth, I don't know, we don't necessarily know the answer, but we'll look into that, and we have your email, and we'll send you along what we learn. Okay, we've got about a minute, and let me look. Question of heat pumps. This is a question of heat pumps. A heat pump for conditioning or water heat, can they be installed in a garage? Will that improve
that
the
question
efficiency? Well, yeah, for you, Matt, for you, Christine.
So for a air source heat pump, I guess you technically could install in a garage in cold climates. That would obviously allow for it to be in a warmer environment than it is outside. The downside, though, would be in the summertime, it would be in a warmer environment than it would be if it was outside. We do know, like in Canada, in some parts of really cold regions of Canada, they do put their condensers what they call a dog house in the wintertime. So they'll cover the condenser so it does recirculate some of its own air and maintain some of its own heat. and then they remove that doghouse in the summertime. I personally would not install a condenser in the garage, just because, you know, I would really want to have that efficient cooling season, which is, you know, something I would be attracted to more so as a consumer. So I left all mine outside instead of mounting them in the garage, but I guess you could if you want to.
Okay, Christine, any thoughts there?
I don't know, what Matt said was good. You basically want to put it where you want to take the heat from, and vent the heat out where you want the resulting air to go to, and it depends which direction you're going, whether you're using it for heating or cooling, and which place is hotter or colder.
Okay. Well, I just want to thank everybody. We've come to the end of our time. We want to respect all your time. There's our contact information. Myself, Matt, and Christine. So feel free to contact us with any questions. We will have this posted on the SWEEP website under events, so you can find that. I'll check into the questions and answers to see if we can download that. I have not done that before, but I'll see if we can download that and
Jim, can I chime in
place
real
that
quick?
up there. Yeah, go ahead.
Yes, we can download all the questions that were asked from the webinar. We'll do our best to circulate those among the presenters, try to get some answers to some of those questions. And we will be sending out a link to the video recording, but like Jim said, you can see it on our website under events as well. But we'll be sending out that link tomorrow in an email to all registrants, along with all the handouts. So yes, Jim, that it might take a couple more days to get those questions answered, but we can do that.
Great. Well, I want to thank everybody. I especially want to thank Matt, thank Christine, thank Kirsten for running in the background, being right there to take over if we touch the wrong link or button. And I want to thank all of you who joined us and spent your time today to learn more about policy, air source heat pumps, and heat pump water heaters. And thank you so much, and have a great day.